So now let's keep doing our discussion on horizon interpretation, right? So here I have imported all the horizons that's interpreted by professional interpreters, and they are stored underneath this horizon interp folder that's inside of the seismic folder, right? That's a new interpretation folder. So if I turn on top tarbert, for example, right, and then if I also turn on the display of all the fault interpretation, you can sort of see top tarbert is actually constrained by default interpretation. So when we actually do this kind of a horizon interpretation, it's kind of important that we do the fault interpretation first, and then use those fault interpretation to sort of constrain the fault tracking in the in horizon interpretation. Right, but now let's turn off the fault interpretation. Right, so that's top tarbert. That's top tarbert. Top knees, and then top eve. Right, top eve. If we look at the seismic horizon 1, it's just a one line actually. Right, it just consists of all the points along one line, one inline cross section, right? So this is just one of those lines that's interpreted or drawn or tracked on one inline intersection. And then if we display seismic horizon 2, it's also kind of on just one line or one inline intersection, right? So now let's try to actually use those horizons as some kind of templates and try to actually track our own horizons, right? So base Cretaceous is actually this particular horizon, right? Let's try to track the horizon that's kind of above the base Cretaceous. You sort of see one event here, right? And this event is actually extended in 3D. So if you sort of pay attention to the to this particular positive amplitude, this positive event, right? It looks like it's actually extending all the way, and then goes around. If you actually look in the other direction, it's actually a three-dimensional event, right? So let's try to track this particular event, right? So let me turn off the display of BCU, right? And then let me see if this event, yeah. So that's actually a horizon with auto tracking attributes. That's also imported from our example data, right? So from our demo table, yeah, that's exactly the horizon that we will try to actually track, right? And base Cretaceous BCU is underneath it, I think, right? That's BCU, right? Yeah. So let's give it a try. So before we actually do the interpretation, let's just create another interpretation folder. Insert a new interpretation folder, and then let's call it. So when we did the fault interpretation, our own fault interpretation was underneath my fault interp, right? So now let's change the name of this particular folder to my horizon interpretation. Okay, and then now I can actually insert a horizon into it, a horizon object into it. So insert seismic horizon. Now we got one horizon object, right? So this you can of course start drawing, and then all the data is going to go into this particular object, right? But before we actually do anything, let's try to set up the tracking parameters. So for horizons, auto tracking becomes really important. So it's kind of important for us to actually set up the auto tracking parameters, right? All we have to do is double click on it or right click and then select the settings. And then we have a tab that's called auto tracking. Let's click on it. And now we can see this auto tracking tab actually becomes really complicated, right? It's not as simple as what we did in the fault interpretation. We now got lots of we got quite a few boxes that we need to actually configure, right? So seismic volume, that's the realized ST8511R92. That's this particular volume, right? That's the realized volume. Priority, amplitude, and proximity. So that's the default setting is actually quite good, right? It's appropriate. Yeah, it considers both the amplitude and proximity. So when we actually try to track a particular event, we have to specify signal feature. It's a peak or trough, and then peaks, troughs, S crossing, Z crossing. So each name actually has a different meaning. So if you would like to actually suppose we select peaks. Suppose we select peaks, right? So it's not exactly explaining what those things are. So peaks actually corresponds to those red events, and then troughs corresponds to those blue events. So seismic waves are actually oscillating, right? So sometimes the amplitude is positive, sometimes the amplitude is negative. And on this kind of three-dimensional display, positive amplitude is displayed in red, and negative amplitude is displayed in blue. And sometimes this kind of display is opposite, right? Some people actually may use blue to indicate positive amplitude, red to indicate negative. But usually in the default case for Petrel, red actually usually means positive amplitude, right? And then if you are tracking red events, then you should select peaks, right? If you are tracking blue events, then you're supposed to select troughs. So, but if you are actually tracking the kind of so from blue to from red to blue or blue to red, you have a transition that's kind of gray, right? And that's kind of a zero crossing. So amplitude at those kind of transition is close to zero. So if that's what you are trying to track, you can sort of select either S crossing or Z crossing, depending upon which direction is positive. So it could look like a S or could look like a Z, and then you are trying to track the. So let's select peaks, right? For quality basic 3x3, so it's going to look at the nearby three traces, inline and cross line neighboring three traces, right? And then parameters, right? See the confidence. This 30% looks like appropriate. So seed are usually refers to those points that's picked by you manually or using some kind of other kind of constraints. So those seed points are usually coming from manual picking, right? And then you have for amplitude seed confidence 30%, and then or you can select some kind of value range, right? So So here, if you sort of try to actually get a deeper understanding about what those parameters actually mean, those are question marks. If you move your cursor to the question mark, actually gives us a quite a clear explanation about the meaning, right? And it's actually explains better than I do actually. So yeah. So. And then what's going to be the spatial distribution on the cross line and inline direction? So suppose you see these here, right? What's going to be the examining range? So in the vertical direction, what's actually going to be the spread that you are going to examine, right? That's so it's either going to be symmetrical, anti-symmetrical, that kind of thing, right? No, asymmetrical. I mean, right? Not asymmetrical. And then what's going to be the value, right? So if you actually increase it, decrease it, that kind of thing, right? So this thing is going to control the spread that you want to look at in the cross line direction, and then this thing is going to control the spread that you want to look at in the inline direction. So each of the wiggle is one seismic trace. You want to track with the, you want to track along the along the cross line or inline direction within this particular vertical range, right? Suppose you picked a peak at this particular location, and then you want to sort of track that peak out in the inline or cross line direction within this kind of an angle, right? That's what this thing is actually controlling. And then use the wavelet tracking. See the trace is like the trace in the middle, right? And then sometimes if you just want to try to find the peak on the next trace, or the trough on the next trace, it's kind of difficult because sometimes the waveform could be really complicated. It's the peak and the trough don't really corresponding to a particular large amplitude event, right? So in that case, you can use correlation. So if you are using correlation, you are going to look at the shape of the wavelet at the zeroth trace, and then compute the cross correlation with the neighboring traces, and then try to find where the correlation is going to be the biggest, and then you track along that location of the largest cross correlation, right? So that's how to use the wavelet tracking, right? Correlation quality by default is 0.8, right? So when the correlation actually reaches or exceeds 0.8, it's going to identify that as the neighboring event. It's going to sort of do a tracking over there. And then if you have finished the sort of setting all the different things, you can just do a click on 3D track, right? But for now, let's not click on 3D track yet, and then let's look at the constraints, right? So in the constraints tab, you can specify different, for example, boundary polygon. You want to just do the auto tracking within a certain range, that kind of thing. Stop at visible force. This one must be checked, right? So if you have a visible force, you display all the force, and then the auto tracking is going to sort of stop at those visible force. But for this particular event that we will try to track, it's not really truncated by a major fault, right? So this thing is not going to, this box is not going to be particularly useful. But if you're actually tracking like a top Tarbert or top Nice, those horizons that's actually significantly affected by the faults, you want to display those faults and then click on this option, that's stop at visible faults. So that's one of the reasons why we need to interpret faults first before we actually interpret the horizons. Vertical limits, on our case, in our time domain data, it's just the time limits, right? Use co-volume, right? So the volume that we are analyzing is actually the raw amplitude volume. That's the seismic data that's directly gathered from the field. We haven't actually done any kind of a transformation on this particular seismic volume, right? But usually seismic data are kind of expensive to get, so you want to make the most out of it, right? So usually you will try to actually extract more volumes or property or attribute volumes from the raw seismic amplitude volume, right? We haven't talked about how to extract seismic attributes, right? Later on, we're going to talk about how to actually extract those seismic attributes as a three-dimensional volume. And one of those very famous attributes is called ant tracking attributes, and then it's kind of an automatic way for identifying faults, right? We'll talk about that later on, right? But if you have extracted an attribute volume, then you can use that co-volume. You can use that volume as some kind of co-volume. If you use a co-volume, then the automatic tracking of the horizon is going to use that co-volume to decide if how to decide how to actually expand or track the horizon, right? Seed and locking. This part is not really used very often, so if you are interested in exploring, just look at the question mark, right? Yeah, pretty much that's the two most important tabs that we need to actually look at. For our exercise, we didn't actually change anything. The only thing that we changed was actually signal feature. We changed it to peaks, right? Because peaks is kind of easier to identify on the interpretation window. And now let's just click on OK. OK. For some reason, it's not allowing me to click OK. So let me just close it, right? So if you expand this seismic horizon 1, you're gonna see a survey underneath it. That's survey 1, right? The reason that you have this particular folder underneath it, this object underneath it, is because sometimes you have multiple surveys. In our current example, there's only one. Survey, right? That's this particular 3D object, right? That's this particular three-dimensional object, right? But sometimes you may have like multiple surveys, right? And the horizon actually goes across those multiple surveys. If that's the case, you're gonna see multiple surveys underneath the horizon, right? So that's why you have this particular survey folder underneath the horizon 1, right? If you have multiple surveys with multiple seismic volumes, two-dimensional, three-dimensional, then all those, and the horizon actually goes across multiple surveys, then you'll see multiple surveys listed underneath the horizon, right? Let me delete it and recreate the horizon. For some reason, I might have done something wrong, I think. Yeah. So now it looks like it's correct. Right. And why do I have this thing here? What exactly did I display? But it doesn't really matter. Let's start to do our so let's go to our interpretation window, right? And for some reason it's already got some lines drawn on it. It's oh, I see. That's the interpretation that I did before. Is it in interpretation 1? Okay, so that's inside of that. Okay, so now let's see how we can actually do this interpretation using the seismic interpretation toolbox. Right. This toolbox, when we did the fold interpretation, we were mainly just using this particular button and then use those selectors and erasers and then this thing to actually edit the shape of the fold, right? And we also have lots of buttons here. These buttons are for interpreting the horizons, basically, right? So suppose let's also put on our display player so we can actually change the. So we can actually. So now we are actually on inline 508, right? Is that right? Yeah, inline 508. That's our intersection. Suppose we would like to actually track this particular red event, right? Suppose we would like to do that. So the first button here is called manual interpretation, right? If we click on it, and then we can just draw on it, right? Click. So every time you make a click, every time you click the left key on your button, it's gonna insert a shape point, a control point or something, right? And if you are done with selecting the shape points, all you have to do is to actually double click, right? As soon as you double click, it's gonna connect all the shape points and then make it look like a line, right? But you can sort of see that this line actually is the shape of this line is pretty much controlled by where we actually clicked, right? So if we actually draw a straight line, suppose we draw a straight line here, then it's gonna the interpreted line is gonna be a straight line. So it's not gonna follow exactly the shape of the event, for example, right? For this particular region, it's pretty flat. Maybe a line is okay, but for these kind of regions, the red event actually has some curvature on it. So if we just do a strict manual interpretation, it's gonna just the lines that's gonna be created from the our clicks are gonna follow exactly the shape of the locations of the clicks. So now let's delete them. Just hold down the left key and then just drag the mouse over. Then it's gonna click erase all the pics. Right? And then now let's look at the second one. It's called guided auto tracking. So it's gonna pick interpretation points and then tracker will follow the optimal events between them. Right. So let's see what's gonna happen. Let's click on it and then let's click on this thing. Right. So what we are going to do is that we are going to hold down the left button of the mouse. We are going to hold down it and drag it, right? So as we actually drag our mouse, the points are kind of tracked automatically. And all the kind of shape points are decided actually by Petrel, right? It's going to be in the vicinity of our cursor's location, but it's not going to follow exactly where our cursor actually is. It's gonna do this kind of it's gonna look at a certain range around our cursor location, and then it's gonna drop a shape point at the location where Petrel actually thinks is most appropriate, right? So when you actually drag your mouse over, you're gonna see that this line actually follows more or less the curvature of the red horizon, the red event, right? So let's also do this thing for this side of the, and then we're done with dragging. Just double click, right? Then it's gonna sort of populate all the shape point, connect all the shape points with the curves, right? So that's the effect of the second button, right? So it's called guided auto tracking, right? And this one is actually used very often, right? So once we have created this interpretation line, if you go back to the 3D window, where is the 3D window? So let's display seismic horizon 1, right? So then you're gonna see this particular curve, this curve that's made up of lots of small squares that comes in, right? And that's like a one auto tracked thing. So a guided auto tracked thing along this particular intersection, 2D intersection. Right? It's not exactly 3D yet, but it's a 2D thing. And then if you actually do this kind of thing multiple times on every cross section, right? So if we go back to the intersection window and then move the intersection by forward or backward by like a 1, so this one is like a 2. So select like four cross sections, and then we can do that again on this particular cross section, right? Oh, it's kind of difficult to track, right? So there's some kind of interruptions here, and Petrel doesn't really know how to actually draw the lines. Yeah, and then if we go back to the 3D window, we're gonna see a second line, right? A second line. Right now it's got like two different. Now we've got like 2 rows, right? 2 rows of these kind of small squares, right? So if we keep doing this kind of thing for every inline intersection, then it's gonna give us something that looks just like the horizon interp BCU, for example, right? So for BCU, you sort of see this kind of tracks, right? This kind of tracks, right? So what we are actually doing is pretty much just creating that kind of thing, right? Similar things, but it's a different horizon. Right. So now let's go back to the interpretation window. Now let's switch to a different. So this is a 512, right? So let's do like one more, and then this time it's 516, right? 516. 516. Let's still try to use a different kind of thing. This one called seeded 2D auto tracking. Right. So this time you are not gonna drag your mouse over the horizon. You're just gonna click on locations where you think you have a good expansion. You have a good chance of expanding, right? So every position that you have clicked is called a seed point, right? And then Petrel is going to try to actually expand to the neighboring peaks or neighboring sort of signal based upon where you actually clicked, right? So here you are just clicking, and then Petrel is going to be responsible for expanding it to the neighboring traces, right? So all you have to do is to click. Right. So if I click once, then Petrel is going to draw a line. Click once, Petrel is going to draw the line. Right. Petrel is going to draw the line instead of I have to do it. Right. So at this kind of location, it's really difficult for me to actually to draw the line, and so it's even more difficult to actually for Petrel to actually draw the line correctly. Right. And then if we actually go back to the three-dimensional window, we should be able to actually get the third line, right? Maybe it's a good idea for us to turn off the inline. Right? So now we see the three bands, right? And you can sort of see some of the points are really bad, actually. Those points, right? It's actually really deviating from the major direction or major trend of the rest of the points, right? But that's okay. Later on, we are going to sort of smooth it and then remove those bad points. Still putting the inline. And now let's look at the next button, and let's switch to one more row. Right. The next button is called 3D seeded, the 3D object. If we click on it, right. So now let's still just use button clicks, right. If we click at one location, we are still seeing just a line on this intersection, right. And that's what Petrel is actually trying to actually expand the seed points to the neighboring points, right? But what Petrel is actually doing is not just doing this kind of expansion in this particular two-dimensional cross section, right? If you go to the three-dimensional window, you're going to be able to actually see. You see, it's not sort of confined to that particular cross section anymore. You now have expansions that's kind of going out of the intersection plane, right? You now have these points. That's not exactly sort of confined to this particular inline anymore, right? So it's actually doing three-dimensional expansion or three-dimensional auto tracking, right? So let's still go back to the thing, and then let's click more. So this is actually a really difficult region. I myself really don't know where to click. Maybe if you are a seismologist, you probably, if you are an exploration seismologist, you might know better than I do. Right? Let me click a few more points. Right. And then let's go back to the three-dimensional window and take a look. Yeah. So in this particular, in this direction where the event is very clear, it can actually extrapolate out of the plane to a far distance, right? And the same is true here. But the thing is that in the middle, where the event is not so clear, it becomes really, really difficult to actually extrapolate, right? And that's why you don't see much of a expansion in this particular direction, right? But if I do the clicking on the cross line, let's maybe we should just use a cross line. Let's where's my cross line? So is this the cross line? So This is the cross line 312, and then this is cross line 450. So which one? Which is my cross line? This one is cross line one. This is the cross line 312 actually. So let's go to the cross line 312. Okay, so now it looks like we are at the cross section of 312. Let me just move the figure a little bit, and we can sort of see a little bit. We can see a little bit of the tracked results obtained from the other from the inline direction, right? And let's just do some clicks, and then try to pick the peaks on this cross line. This cross line might be easier to pick. Right, and then once we're done with this line, we can flip one more. Right, so for this neighboring track, that's like 10 cross lines away from it. We already have some of the picked points, right? Those picked points were automatically tracked by Petrel, and you can sort of see they are actually quite accurate, right? It's pretty accurate, except for those regions that we don't, the human don't even know how to actually pick. So Petrel doesn't know either. Right. So let's go back to the 3D window. And then let's do the picking in the 3D. Let's do the auto tracking in the 3-dimensional window and see how Petrel can actually do that. Right. In order to do that, we need to actually open the inspector. So if we click on inspector, it's gonna give us this dialog box. This box, not exact dialog. And then we turn our cursor into this pick mode, and then just click on any point of our horizon that we just picked. And then we're going to have an option that's called a horizon tracking, this particular thing, horizon tracking. Let's expand it, right? And then it's going to give us some of the basic things, basic options. That's kind of a basic parameter settings that we have already seen inside of the auto tracking settings dialog box at the when we actually right clicked on the horizon, right? Where is our horizon? It's called my horizon interp, right? That's when we actually right click on the seismic horizon and then click on the auto tracking tab. We sort of see some of those things. For example, priority, amplitude, and proximity, right? And wavelet tracking, city trace, that kind of thing. Let's click on stop at visible fault. We don't really have any visible fault here. And then we have this kind of cycle button here. It's called 3D tracking. If we click on it, no visible fault found. Maybe let's so there's no visible fault. Let's sort of uncheck this thing, and then click on this thing, and then it's gonna start to compute the auto track surface, and you're gonna see it's gonna expand. Right, you have a larger surface now, right? And then do that again. Right, now you've got another larger surface now. Right. So every time you click on this 3D tracking thing, it's gonna try to actually create. It's gonna try to actually track more traces based upon the seed traces the seed picks that you have already picked by hand. Right. And you can actually control the kind of spatial expansion of it, how it's going to be connected in 3D. But it looks like it's having difficulty in those big regions, especially on this particular region, right? Maybe let's try to move this particular inline or cross line. It's inline 512, right? Let's move it over. It's not allowing me to drag. Oh, strange. Now it's sort of moved. Right. And then let's also move this cross section over. Oh, it's just because my computer is slow. And then let's go back to the interpretation window and see what we have there. Yeah, it's kind of difficult for Petrel to actually track this kind of horizon. It's very discontinuous, right? So let's maybe let's just do a 2D see it. Let's just guide it auto 2D tracking. Maybe let's switch to a different line. Let me move my. Oh, this is a kind of a fragmented, very difficult to draw. Okay, so maybe that's the best I can do. So it's not really a good idea to actually do this thing in the video. So probably should have just picked all the horizons. So now it's expanding a little bit more, right? So it's expanding a little bit more into the hole. But still, it's having difficulty actually connecting all the different points. So this is what I'm doing here is not so accurate. It's because it's Petrel is actually having difficulty to connect all the different points into like one service, right? In practice, you may want to spend some more time to play with it and try to add more seed points manually, right? If you have this kind of, if Petrel is having difficulty sort of doing this kind of auto tracking. Right. But for this particular video, I'm just gonna do this quickly and then try to come up with a usable service as quickly as I can. Is that dense enough? Again, we still have lots of holes in the middle. So this is not ideal yet. This is not very good, actually. It's not good at all. It's not good. But anyway, I think it's probably a good time for us to actually stop doing this thing, right? So now we've got a sort of a tentative a kind of an experimental thing, experimental sort of horizon. Later on, we can actually try to edit it, and then clean up this horizon, right? But let's look at what's actually underneath the horizon, and then what's actually underneath the 3D filter, right? So underneath the 3D interp inclusive filter, you have all those different choices, right? Are you going to display 3D tracked? If you sort of turn it off, it's gonna just display the manually picked or 2D picked lines, right? That's pretty much the 2D picked lines, right? So if you want to put on the 3D auto tracked, then that's you got lots more points, right? 2D tracked, if you turn it off, all those two-dimensional auto tracked lines, things are going to disappear. Manual, and those manual tracked are going to disappear. So those filters allow you to actually select or control the display of the points that you got or the picks that you got using different kinds of methods, right? And then underneath survey 1, you got the two-way travel time is just the color that you're actually seeing here, right? But if you want to see the confidence, so when we did the auto tracking, especially the 3D auto tracking, there's going to be a value that's called confidence that's going to be computed based upon how confident the Petrel actually is, where it actually does the auto tracking, right? So sometimes Petrel doesn't have a very high confidence, so the value is going to be low, right? But it looks like it's the majority of it actually has very high confidence. Right, the majority of the points, except for some points sort of in the middle, right? These locations, the confidence is not so high, but otherwise it's pretty much all red. The confidence is close to 1 already, right? And then amplitudes. So the amplitudes. So these 3 quantities were actually created for you to actually to do the so-called quality control of those tracked those picked points, right? So distance indicates how far away those auto-created points are from those manual picks, from those seed points. Actually, so if you are very far from the seed, then maybe that's not so good, right? You want to be close to the seed, right? So that's so let's still go back to two-way travel time, so we can see the value of the two-way travel time, right? These 3 parameters were specified. Let me right click on it, and then settings. Do we have an output pane? Auto tracking. So it's not specified inside of this particular tab. In the past, it was specified in this particular tab, in this particular part of the tab. Filtering. Okay, so filtering. So filtering is another useful property for you to actually edit. So suppose you want to remove this part of the selection, right? So attribute filter two-way travel time, right? So now it's displaying the two-way travel time. So maybe you have noticed that we have some locations where we have very high elevation or high TWT value, two-way travel time values. Suppose you think that this part of the value is unreliable. It might corresponding to a different horizon or something, and then you can select. You can get rid of that, right? By you have a gray line here, right? This gray line allows you to actually filter out this portion of the data. Suppose you want to sort of get rid of it, right? And then two-way travel time is just one of those things, and then you have confidence, right? So okay, so confidence doesn't look like it's got a very smooth distribution. It looks like it's all concentrated at 1, but maybe that's amplitude. Let's look at amplitude. Yeah, amplitude gives you some kind of distribution. Again, you can filter it based upon the amplitude, how strong the event actually is, right? And then distance to the seed point. Okay, so it's not too far away, right? So that's the filter. It's also a quite useful capability for you to actually quality control. Quality attributes. No, that's not quality attributes. Statistics. That's statistics. Yeah, anyway, those outputs used to be used to be you used to have to specify those outputs inside of a certain tab. But for now, I just couldn't find it. I just cannot find the particular tab that's going to allow you to specify those outputs. But anyway, that's but maybe it doesn't really matter too much because it's already created, right? And then you may wanna do some quality control, right? So for now, seismic horizon is active, right? So you got a context aware tab that's called horizon. If you click on it, it's gonna give you a bunch of buttons. Right? So there are multiple ways for you to actually select points, right? Select points. You got this interactive eraser thing, right? And then you got these two buttons called select parent points and select child points, right? So sometimes some of the points were picked or auto-tracked that are based upon certain kind of seed points that may have been drawn manually, right? So if the auto-tracked data is no good, If the auto-tracked points are not so good, and then maybe that's because the seed points were selected wrong, right? If that's the case, this button is going to allow you to actually select the parent points, right? If you have identified which seed point actually has problems, use this button to select all the child points that's derived from that particular parent point, right? And then you can just use some kind of eraser, either this kind of interactive eraser or some other eraser to delete those points, basically, to clean up those bad points, and then maybe do a retracking or something, right? So all those cleanup are actually very, very important before you actually use this particular service to do any kind of structural modeling, right? But let's look. We haven't actually done much of a quality control. We haven't actually do the editing, right? I'm just telling you how to actually do those quality control, right? You probably have to use those buttons to select the different kinds of points, right? Use those buttons to actually select the points and do the deletion, that kind of thing. And then use those filters. Use those filters to select the particular type of data, and then use those indicators, confidence, amplitude, distance, those kind of indicators to decide if you want to make a correction or not. Right? All those things are there to actually help us to quality control the picked points. And then what's going to be the next step, right? What's going to be the next step? Let's double click on surveys. It's not the horizon, it's the survey. And then if you click on the survey, and then you're going to get an operations tab, right? And then underneath the operations tab, we've got lots of things, right? One of those things is called convert points. It's not this one. Let's look at the seismic operations, right? So seismic operations, one of those things that people often use is Gaussian smooth, right? So iteration 1, by default, it's iteration 1. If you click on run, then it's going to try to actually smooth the interface, smooth the surface that we have just created, right? And if running once is not enough, you can try to run it multiple times. Then it's going to make the surface smoother. Do you see? So every time you click on it, it's going to make the surface smoother, right? I think I did those points wrong, completely wrong, I think. Right? There's a horizon on the that maybe it's supposed to go this way instead of this way, right? It's very likely it's not supposed to go this way. So maybe I should just delete those points. Let me turn off the. So if you use a eraser, you can just delete them very easily. Or you can just use a selector, right? You can use a selector to actually select this portion of the points and then delete them by hand. right? So I'm probably also deleting some of the good points, right? But it's okay, doesn't matter too much. For this particular example, it's let me change my cursor to the viewing mode. Again, this is a slow computer, so that's why it's not so responsive. But now we have created a huge hole in the middle of the uh, of the interpretation, right? It's a pretty big hole. I just don't know if Petrel actually can handle it, right? Maybe what can we do? Still put on the inspector, and then let me just pick the horizon. Let's do one more checking. Is the hole smaller? We don't know. Okay, so it starts to actually deviate again. But anyway, and then the next step after the quality control, after you have finished editing all those points and correct all those or delete all those incorrect points, the next step is to actually make surface, right? And then at this point, you can just point your horizon in. So now let me delete it. Let me delete the previous input. Right? And then we can just choose the horizon and then point it into the input data. And then a boundary, maybe let's use the project boundary thing. Do we have a project boundary? Project boundary, okay. So let's point it in there. And just use auto check. Suggested settings, that's the seismic lines, high density. Right? And then just click on OK. Then we will be able to actually create a surface, right? Okay, so this is a very rough surface. It's a bad surface. You can see lots of plateaus that's sticking out of the surface, right? If we actually turn off the visualization of the horizon, right, you're gonna see the surface. It's a bad surface, right? So this interpretation was not done very well. So it's a bad example. You should actually take this thing as a bad example. We're not supposed to have those things sticking out. Right? We haven't actually done much of an editing. Right? Maybe this plateau is like a real, right? But this kind of peak is definitely not real. We need to actually manually sort of get rid of it. And I'm not sure this plateau is actually real. And I'm not sure this particular low point or this kind of valley thing is real either. I'm not exactly sure. Right. So we need to spend more time to actually do this kind of editing thing. But now, if you go through all those processes, now you've got a surface, right? And this kind of surface, if it is done correctly, then you can use this particular surface for building your structure model later on, right? When you insert the horizons into the pillar grading created mesh, right? Those kind of things, you can use those surfaces to create the horizons, right? Yeah, this is probably a good place for us to actually stop. Next time, we'll talk about slightly more complicated